Okay, so this video is going to help explain to you the idea of the derivative as a rate of change, which is something we've already been talking about. We've already established that the derivative is a rate of change. Now we're going to look at the derivative in the idea as of rate of change as a velocity or as a speed. Remember, a derivative is the same thing as the slope of a tangent line. And remember, slope is y2 minus y1 over x2 minus x1, which hopefully you'll see that's the same thing as the rate of change. And so what we're going to relate this to is that now we're going to look at a rate of change as a velocity of an object. And so what I want you to kind of make the connection is that the derivative, if we have an object that is moving through space, the derivative of that function, so if we have a function s of t equals 16t squared plus 32t, this is the function that determines its location. If we take the derivative of that, s prime of t, the derivative of that gives us the velocity. So basically, that's what I want to impress upon you in this video, is that the derivative of a function is that function's velocity. So first we're going to talk real quick about a simple problem, average rate of change problem, which is something that you have already seen. So for example, if you have a function f of x equals negative 6 over x, and you're asked for the average rate of change over the interval 1 to 1.2, there's nothing new about this. This is just basically find the slope of this function between these 2 points. And that's the solution to it. It's basically y2 minus y1 over x2 minus x1. That's all that's going on here. Obviously, you're going to need to find the y value, the corresponding y values for these 2 points. And when you find those, this is pretty straightforward. The main thing I want to get to now is to show you the idea of the instantaneous rate of change. So if you're asked to find the average rate of change between 2 points, you don't need to use calculus. You can just use algebra, as is demonstrated here. If you're asked for the instantaneous rate of change, that is the rate of change at a single, that's the velocity at a single point in time. So at the single point in time, you're not going to have a y2 and a y1. You're going to have a x1, you're going to have a y1. You're not going to have 2 different points. So that's when the derivative comes into play. If you have a function such as s of t equals, again, 16t squared minus 32t, if that function determines the location of an object, then if you find s prime of t, the derivative of t, which in this case would be what, 32t minus 32, the derivative is going to give us the velocity, the instantaneous velocity. So this is the same thing as saying v of t. So you can see that really quickly, you can, if you have the location of an object, you can quickly find the derivative of that, get the instantaneous velocity. Okay, so for example, if we have the function f of x equals negative 6 over x, if you want to find the instantaneous rate of change of f of x when x equals 1, you're just going to find the derivative of this function. We're having issues with this thing. Okay, this should say f prime of 1. So the rate of change at x equals 1 is going to be equal to the derivative of f at 1. So if we find the derivative of f of x, The derivative of f of x is going to be 6 over x squared. So now we just want to plug 1 in for x, and then you get f prime of 1 is going to be 6. So do you see, and we just took the derivative here, we said f prime of x equals negative 6 x to the negative 1. Well, that's not f prime, that's the original function. So when we take the derivative here, we get f prime of x is going to be 6 x to the negative 2, which gives us 6 over x squared, in case you were wondering where that came from. Okay, and I'm going to separate these two videos out. The next video is going to work through two problems that should help you with your prep quiz.